Great. So, hi everyone. Thank you for joining us today on another webinar in the seminar series. Excited to have you all here. And today's topic is flipping the feedback loop, some experiments in reflexive and student-driven system dynamics education. We have IIM Calcutta from MIT Sloan here today. And I just want to take a brief moment to invite you all to join us at the ISTC 2026, the International System Dynamics Conference. We'll meet in Delft, the Netherlands next year from July 20th to 24th. And we already have a team, so it's navigating uncertainty and instability, crafting futures together. So really hope to see you, everyone there. And if you cannot join us in person, you can also join and participate online. A brief reminder for all of our society members, and if you're not society members yet, you can join us for a 12-month membership and get access for a pool of benefits such as free access to the seminar series, including the recordings from past 50 webinars that we already have, discount in our annual conference. And if you're planning to learn more about system dynamics, you get access to a pool of mentors with great mentorship programs. And today we have IIM Gupta from the MIT Sloan. She's a system scientist focused on redesigning how institutions learn and evolve. With over a decade of experience leading complex projects, she's now pursuing her PhD at MIT, where she studies how capital influences feedback and incentives across business and society. Her work spans healthcare, education, combining research, consulting, and teaching. Through her systems lab, Unbound, she collaborates with organizations in India and in the US to prototype new approaches to investing, decision-making, and learning systems. So thank you all for being here, and thank you, IIM, for agreeing and contributing to the seminar series. That's all from my side. I'll be here with you, checking the chat, and let me know if you guys have any questions so far. And thank you for joining.
Great. Thanks a lot, Fernando, for that introduction. As we get started, so I've been teaching system dynamics for the last 6 years, and I've been running the course at IIM Calcutta in India. And then there are a couple of universities across India and a few outside of India as well that I have done guest lectures, workshops, etc. at. So a lot of the context of what I'm going to be talking about actually relates to my early experiments, especially at IIM Calcutta and a couple of other universities where I did my foundational system dynamics teaching. Again, as the title suggests, there is a reflexive component over here, and that sort of lends itself to my journey as well. The course that I took on at IIM Calcutta was a course that I passed through. So it's almost now 11 years ago that I took that course. It was an elective course as part of my MBA. So it's a business school oriented course. It's called Business Dynamics. And in 2019 is when I started to sort of be a visiting lecturer in that course. And then over time, I took on that course and I did 30 hours of teaching. Before that, there were also a couple of experiments with 15-hour courses to sort of see what the learning trajectory will be. And so a lot of these insights come from the history of the course and how it has evolved, to which I give a lot of credit to Professor Rahul Roy, who has been my mentor of this journey. On the second front, there is, my experience as a learner of system dynamics and how long it took me to really understand how it works. And currently I'm pursuing a PhD, so in no way am I an expert at system dynamics yet. And then the third piece is experimentation, collaborating with Professor Roy, and then there are other universities where, people were hosting this course, where we ran some experiments with the design of this. And that was informed a little bit by George P. Richardson's papers on model teaching. I don't know how many of you are familiar with that, but if not, they are a great resource to really think about how to design the structure around model teaching. And then lastly, then as I learned, so some of what I will be showing today is almost like it's work in progress. It's not the final output. There are lessons that I've taken away from there. that I would sort of recommend and experiment with further. So nothing is really complete. So that's what the context of this is. And now, before jumping into the content, I want to hear from you guys, and I see most videos are off. So one, it would be lovely if I can see the people that are behind the cameras. Second, if any of you have teaching experience with system dynamics, or even as a student, what your experiences have been, I would love to sort of start with that. And this will actually be sort of the design of this session as well. It will be a little more interactive. That's how I keep my classes as well. So hopefully this seminar will also not be as one way, and will invite a lot of inputs from you, and eager to hear from you. Like, any thoughts on the title itself, any experiences with teaching system dynamics or learning system dynamics, and what have been some of the challenges that you've faced?
Yeah, and feel free to share your thoughts in the chat, or just go ahead and mute yourself, and you're free to comment as well.
I see a lot of people who have actually taught. So I would love for you to talk about your experiences. And people who've been students, I'm sure that system dynamics is not easy to learn. So feel free to sort of jump in on any of those struggles that you faced, any of the criticisms with respect to how the methodologies are designed, or recommendations or considerations.
I'll go ahead and make a comment, Akriti. I think, I studied system dynamics back in 2016, my master's degree in the University of Bergen. And I think there was a lot great. I got probably the best instructors in the field, but there was a lot of self-training as well. There was a lot of self-learning with videos and books. So I think there is a really important part of learning system dynamics is this time that you spend by yourself modeling and just learning by yourself.
That is true. I'm actually doing that right now. I thought I'm doing 873 is what the system dynamics base course is called at MIT. I thought it would be a cake and walk in the park. For me, it's not. So even after sort of teaching it, being on the other side, I feel like I'm still sort of struggling with it. So we have a couple of chat comments which I'll read out loud, but if anybody has points that they want to make, please feel free to raise your hand. So we have Julia, who shares that she has taught systems modeling, especially CLDs, which are definitely very challenging, and to help enduring agreement in groups. So yeah, this relates to the group modeling exercises, which has really sort of emerged as a great participatory technique in the recent years. Then Christine has done a couple of SD courses at WPI. No experience teaching is SD, but have graded for an undergrad intro SD course. So I'm sure grading for system dynamics is really difficult. I think that, when I had to unpack the models, etc., it was just hard. But at the same time, there is a method that I'm going to demonstrate over here, which really makes it a lot easier. And it is, funnily enough, it's very scalable. So the larger the classroom, the better it is. Then John, do you want to speak? Do you want to share that, John?
Oh, you mean just go ahead and talk about it? Yeah, so there isn't enough sort of basic system dynamics teaching that goes on in any part of the curriculum at Colorado State where I am teaching this course. So to introduce it to students, and these are basically seniors in soil science, where they've had exposure, I think, to dynamic thinking or dynamic models, but don't really see the SD fundamentals underneath it. That I had to spend, you have to spend time starting from scratch teaching basic SD concepts and then try and introduce things like Stella so they can actually start doing some of their own work. And then I get to the topic of applying the SD to the topic area that they're interested in, which was sustainable food systems.
Oh, yes. So I have this on one of the slides, but basically the problem with system dynamics, what you're articulating is that there is a need for learning the software, the causality, the concept of causality, then the domain that you're working on, and then math. And all of this has to be done in like your course timelines. And the software takes some time to learn, as well as the causality concepts, which, to be honest, I mean, I don't know whether this is the case for everybody, but I think that over the last 10 years, they have really sort of evolved my thinking and perspective of what I experience around the world. So, which is where the systems thinking part sort of combines with the system dynamics modeling part.
Yep.
Nikki, do you want to go ahead? And
yeah, just to share some kind of challenges. And when I remember myself as a student, but also what I saw in my students is that the first system dynamics models, even if from our perspective they are quite small, they are big and complex, right? Something like the urban dynamics model, the project management model, the worker burnout model, like seeing that as your first and second model is very big and challenging. So one of the things that I started doing was to implement a group model building approach to this. So for example, rather than kind of presenting the students with a full like developed system dynamics model, I started building a simplified version as a group model building project in class, or I teach system dynamics concepts like what is a link polarity, what is a feedback loop in a group model building setting. So kind of, yeah, I think there are many ways of how you can use this to teach like the concepts, but also specific content knowledge or subject knowledge or participatory modeling. Yeah.
Right. So instead of like a one teacher talking to the entire class, you split them into groups and they're working on little problems around.
Yeah, or you do it with them, right, as like the facilitator, and that's a more fun and engaging way to learn, I found. And also it gives them also like then a step into the model, which is then not so daunting anymore for them.
Oh, yes. That's great advice. All right. Anybody else wants to jump in? And I've actually seen Nikki's Romeo and Juliet model, which I talk about to any person who's sort of new to system dynamics. If any of you do not know about it, just Google it. There's a Romeo and Juliet model that she had built, which I think is great for introductory learning. All right, so in the interest of time, I'm gonna jump into the slides. So why does this matter? System dynamics is the only course that truly teaches feedback thinking. And I mean, I think this is a shared belief that it should be introduced way sooner in curriculums, maybe even at school stage, etc. But whenever we start, we have to start from scratch. And it's often overwhelming, siloed, and short-term in impact. This I've experienced, especially in business schools, where the coursework, like when the course is over, there's a lot of questions that students have with respect to what is the utility of this? Why did we learn this software, which we are not going to really use? And so, you know, the abstract and the esoteric learning sort of gets a little deprioritized if you sort of make system dynamics a little more focused. And I have been struggling to balance the two. The other thing is that it takes time to really let the learning sink in. So how do you get people to experience systems has been a question that I was sitting with. Now, some inspirations. So these are some quotes that I had seen like long back. And I kept them with myself. And when I was designing the course, I thought about this and I reflected on the course structure basis these quotes. So they go that the goal in any system of learning is to develop the learner's understanding of what quality looks like. So the learner can judge and modify their own work. Rubrics can be a powerful formative tool in the formative assessment process. Now, as I looked at this, I realized that system dynamics and modeling and systems thinking, people don't really know what quality looks like. One person's mental model or one person's model is going to be so different from another person's model. So how do you create a rubric that actually sort of works? The second piece is that around feedback, which is focused feedback, provides a learner with specific information about the components of the product that are done well, areas that can be improved, and insights on how to improve. The amount of focused feedback depends on where the learner is in the learning process. So you can't overwhelm a new learner with a lot of feedback, and therefore you have to sort of manage different learning journeys. A couple of other things that my course design was inspired from is one was UDL, which is Universal Design for Learning or something like that. I'm forgetting the full form, but basically it says that different people have different learning styles and different strengths and weaknesses, and so having like a one size fits all approach does not really work. So how do you sort of give flexibility to different learners to allow the coursework and the assignments to actually fit their personal considerations? This also ties back to, I almost feel like my learning style is very, very different. And so I have sort of struggled in a more streamlined, structured course format or pedagogical format. And therefore, I was looking for models which would accommodate some of my quirks, which is like, I would get my best work done very close to the deadline. And every time I would be reflecting on, oh, if I had 3 more hours, this would be a wonderful output. And I just knew that the marginal improvement would be massive. So what did I do for that? I actually introduced for students a negotiation tactic in which they could sort of push the deadline and take, let's say, a penalty of 2 points on the basis of how much of a deadline expansion that they needed, which meant that for a person like me who really works very well close to the deadline, like that 2 marks penalty is actually way lesser than the marginal improvement that I would end up making. So 100% I would have taken it. Or maybe I would realize that there is a cost or a penalty, and therefore I would just push myself to do it in time. But sort of introducing market frameworks. And other designs in which the grading component was not just about modeling, but also about other pieces. And sort of that also required a little bit of negotiation with the university to allow for that accommodation, because the structure and the rules around this don't allow so much innovation. Now we come to the problem in SD teaching. One is that there is a systemic problem of the steep learning curve. So what John was talking about, right? We had to collapse all of this in 30 hours. And my intent is that I want my students to go away, not as expert modelers, but as having appreciation for systems thinking, which means that they need to use this robustly. They need to apply it to the right problems, and they need to sort of develop at least the foundations of systems thinking capabilities, which will take them very far in life. Like my class 11, 12 years ago, I did not become a great modeler after that class, but it sort of provoked in me this idea that, hey, things are connected. Can I figure out what those interactions are? How can I apply it to my own life? And from a mental modeling perspective, it really shifted the way that I viewed the world. The second piece is that evaluation is sort of misaligned with systems learning, and there are 2 components to this. One is that the traditional mechanism, at least in India, is that your 50%, almost 50% of your grade happens after your final project submission or after your final exam. So, which means that you receive feedback or you receive a grade, basically. It's not even that, the feedback is not even that detailed, but what feedback you receive is actually coming at a time when you already have immersed yourself in, let's say, the next semester, or you're now on holiday. And so you're not invested anymore, right? So the idea was that, can this evaluation come at a time when you're still on this learning journey, and that feedback actually links back and enhances your learning, enhances your motivation? That was the second part. The third piece is that people have been struggling with figuring out real world or industry applications. Funnily enough, a lot of people in my course applied for the course because they thought it's going to help them with product management, which I was very surprised by. Although I see how it can have utility, but that's not what my course was designed around. And yeah, students disengage post-course. This pressure is even deeper. I think in undergrad courses, there is still some room. You have longer semesters. In an MBA course, the timelines are too short. And then there are multiple courses, as well as placements, as well as, you know, like your social life, etc., which are sort of competing for attention. And then another qualifying problem along with that is that by year 2, which is when this elective was placed, people's grades are locked. So their motivation is it's almost like a nice thing also, because you get people who are actually motivated for the course, but it also means that they're not willing to put in as much hard work if you're not getting them excited in the first few sessions. Now, I already sort of touched upon this, but this builds a little bit on group model building, very importantly on George P. Richardson, who was at SUNY. His papers on model teaching, he has 3 of these. If anybody is interested in that, I highly recommend those. They really talk about how to teach model building, and a lot of experiments that Professor Roy and I undertook initially were sort of inspired from this. The third input was my personal learning experience. And so where I felt that the learning curve of this course could have been better. And Professor Roy was very, very open to making those experiments happen. And then the other thing is that he brought in a lot of gaming for learning kind of interest. So we used the beer game. We used to use salt cellar, fish banks, etc. So all of these simulations to really sort of make it land. And I think the beer game, for example, is a great game which gets people very excited because it gives them results that they're not expecting, and they're just so perplexed by what happens in the game that it just enhances the curiosity of people who are part of the classroom. And therefore, the goal was to redesign the learning system, break the feedback loop, not sort of backload it, but sort of front load it a little bit, allow for a lot of hand-holding during the initial periods, which was a big scale problem because I did not have a lot of TA support. The TAs did not know system dynamics. And so I had to sort of do the grading, the feedback, etc., all by myself. And I was not a full-time faculty as well. So I had a consulting career, which was running parallelly to this, which made just the time management of this very problematic. So that was a scale constraint. In addition to this, again, COVID gave us some really interesting tools like Mentimeter, etc., which we sort of introduced into the in the gameplay. So we shifted this loop to this loop. Okay, I'm gonna now pivot from the slides and actually show you and talk through some of the things that we did. So we primarily, give me a second. So the first problem, so again, model teaching talks to you about, you first introduce a model and make people sort of play with it. So for that, we use the Kaiba Plateau model. Are any of you familiar with that? The Kaiba Plateau?
Some.
Okay. So Kaiba plateau is basically a growth overshoot and collapse example, and there is like a ready model for it, a ready problem statement, and it allows people to sort of test policy options. So it sort of has a lay in the land of deer population that is growing, predators are removed at a certain time period, and students are asked whether what is going to happen to this ecosystem over time. And so they simulate the model. The model is given to them. So it's ready-made and it's given to them. And once the model is given, people simulate it. They see the dynamics of what's going to happen. And then you can actually hand them an assignment which asks them to experiment with certain policy considerations. So the policies that you're choosing is either you introduce prey, or you manually, or you basically harvest the deer. So you're catching the deer and you're removing them from the ecosystem because the deer population starts growing really fast. And so in this environment, what that does is that WenSim is really hard to sort of get used to, and doing a blank slate mapping of any model is really hard for students. So what the objective is to get people familiarized with the interface, with what is possible, with running simulations, and not have them really sort of worry about having to think about how to build a model, which it takes time to build, to conceptualize a model. And so Kaiba Plateau is a great introduction into that. So that was primarily like the first stage of the course. At the second step, it was introducing COVID modeling, or modeling of an epidemic as a problem, which is again now a familiar problem for most people. And it introduces the concept of diffusion or virality or whatever, right, which is used across so many models. So you introduce the COVID model in class, you talk about the stock and flow structures. And this is, of course, after we introduce the feedback loops, polarities, and all of that. Then you introduce basically the COVID model and ask people to develop an intuition about what's going to happen if you choose certain interventions. I had run a couple of Mentimeter questions, so I can actually show you some of the results of those. And these were sort of discussed in class. That will just visualize what I'm talking about. Yeah. Okay. So basically, we had on the board, we had a model of COVID dynamics, and we have the SIR model laid out. People have done it as part of an assignment. And now you're trying to interrogate what will happen with different eventualities, different conditions, different scenarios. And this is like the results of a poll where I'd asked, in a classroom discussion, people were supposed to come and modify the diagram on the basis of these interventions. So how do you modify the diagram when a vaccine sort of emerges? How do you modify it when you have asymptomatic spread? How do you modify it when there is a national quarantine requirement? If there's a prolonged mobility reduction, which is basically a lockdown, if you have waning immunity, the feedback loop backwards into from resolved to susceptible, mutation of the virus. So this happened by year 2 of the pandemic, and this was not part of the model originally, but now you're asking the question that how will this impact infections and deaths? And so within the classroom, people are now modifying their diagrams. And then we had a discussion on which has the most power to impact infections and deaths. I'm not saying this is the correct answer. This is what the classroom votes were like. And then there was like a debate and a discussion about why, which modification will lead to a higher impact versus a lower impact. Most people, as we can see, thought that vaccination has the highest impact in reducing infections and deaths. Again, many of these things depend on the parameter values as well, which was, again, the intention to open up that discussion and to get people to respond to that. Another interesting thing that came up is that this helped people sort of almost visualize the leverage points, because we were parallelly doing system dynamics as well as systems thinking. So at this stage, I had introduced Donella Meadows' 12 leverage points framework. And so how can you link some of these interventions and how they impact the model structure with the leverage points that we see on the 12 leverage points? So it really sort of, enhances the discussion and reflection that people are having. So this is almost like stage 2, where now the students are able to build simple models and they understand feedback structures and they're understanding how policies are interacting. After this, there was a bigger problem that we worked on, and that was a longer problem, which was looking at the health system. Actually, let me just touch upon one thing before this. Another thing that I was getting consistent feedback on is how many, so with every assignment, I used to estimate how many person hours it should ideally take, so how much buffer they should hold for this assignment. And then we used to have a voting on whether they met that time or whether it was less than that, higher than that, et cetera, et cetera. As we move forward, actually, this got way longer. And that is one of my feedbacks, because I thought that a certain assignment will take way lesser time than it actually took. Then the third step of model teaching, and I'm not exactly going by order over there, is to build a model. And so model conceptualization is a hard piece if students are working with their own problem statements. When I had taken the course, that is what the assignment, that is what our project used to be towards the end, to choose a problem that we're interested in and then build a model, run simulations, compare it with the data, and sort of give policy recommendations on it. My experience of it was that we were not really robust at modeling. What we built as stocks versus flows for a certain problem was not really robust. And so I thought that I did not feel that by, let's say, lecture 10, which is almost 15 hours in, you're mature enough to conceptualize a problem which would be relevant enough to make a model by yourself. And so this was a choice which I feel a little bit on the fence on. I chose to sort of work on one singular large problem and a complex problem. So what we worked on reimagining the healthcare system and modeling the demand as well as the supply side, as well as the population aging chain, and what are the incidences and healthcare capacity demand for each sector of the population and for different kinds of healthcare needs, which is actually quite a complex model, to be honest. But so the process of this was to help first surface with discussion. And there was also a guest lecturer who was a healthcare expert at this time who came in and talked about the health system. We broke down that problem into a stock and flow structure, which I think is like the spine of the model. Post that, we worked on what are the different interactions. So building the healthcare demand side, and what are the most important variables over here, getting data for it. And these were distributed assignments, but it was also sort of being worked on in class, and students were supposed to complete and basically figure out the matching between the supply and the demand side. And I'm going to show you one of the models shortly. And this submission was supposed to be an interim submission. And then there was a lot of feedback which would help people improve their models from there. And then they work on the final problem statement, which again, I kept it linked to that model because making a new model at this time did not make sense. And we had a really robust model. So now, second. Now let me quickly show you the model that we built. Can everyone see my screen? Okay. So this is basically a schematic of health stages where the population is in terms of age, health, etc. And we used some pre-existing structure and mapped it to data to figure out that can we actually map data to this. Then there is a demand capacity, which is generated over here. I will just sort of show a couple of variables that are used. So for example, what is the demand for hospital beds? And that's generated from patients in need for specialist care. So we broke it down into specialist versus generalist care. And then also the demand was split into acute versus sort of chronic problems, number of PHC visits needed, average duration of each visit, and therefore what is the total latent demand, what is the express demand, which is sort of limited by accessibility as well as affordability, as well as awareness. This is not geographical at this point of time, it's more aggregated. And then we have the healthcare supply side, where we're looking at how many medical graduates there are, because we're running this over a period of 50 years or so. How many of them are primary care, specialist care, how many hospital beds are there, what is the nurse availability, etc., mapping all of that. And then we are computing DALY, which is the target indicator. So what is your disability adjusted life years? That was the goal that we were working on with different policies, etc. Can you improve your DALY rates? And how does the demand and supply interact to create a better or a poorer DALY rate? Do ask questions if you have any on this, because this is again a little more detailed on healthcare. And then here we have shareholder value. So this model currently is actually part of the final submission, but this is the use case that we used. Like till here is what the interim assignment was about, which is what are the different health stages, and on the basis of that, what is the healthcare demand? How does that interact with the healthcare supply? Is the demand meeting the supply? If not, what is the gap, etc. And then therefore, what are the DALY rates? And then as part of the final assignment, you had to look at what is the valuation potential for building a managed care model within this ecosystem. And there were other options as well. We also looked at, again, because this was a business course, so people had the option to choose. They could either go the policy side, where they're looking at between Kerala, and which is a more advanced, mature healthcare capacity state, and Bihar, which state needs what kinds of interventions to scale up its healthcare supply to meet the demand that it's generating. And that's supposed to sort of surface the fact that different contexts and different environments would need different sort of investments. So that was one of the policy kind of use cases. Then this one was more finance related, where you're looking at what is the way that you can create shareholder value in this ecosystem. A lot of Indian healthcare is actually private. And the out-of-pocket expenditure in India is more than 50%. And therefore, commercial healthcare has to step in. And so can you get better shareholder value while also improving DALY rates? So that's the model. I will pause here for any questions.
I have a question about how much of this detail modeling did the students do from scratch versus you're guiding them through the building of the model?
So I did not actually build a model. I help people sort of conceptualize the structure. So this is almost like in the classroom, you're drawing the stocks and flows, figuring out what the equations could broadly look like. And then people had to, students were assigned the task of converting that into model and mapping it to real data. So for example, if you have for the birth rates, the fertility rate, etc., you will find out by yourself and you will feed that into the model. The broader structure of population split into different stages so that it makes sense logically and is also able to sort of relate very neatly to the healthcare demand was something that I supported the students on. Any other questions?
Akriti, I was wondering to what extent that the kind of basic rationale behind this whole exercise, meaning, as far as I understood, that you try to, in a way, optimize the daily rates based on supply and demand and the kind of policies that affect both, was ever contested? Was that rationale ever contested in the classroom by the students?
There was contestation on the structure of the model, but policy impact and recommendations were part of the final submission. So they did not form part of like a broader group discussion. And I would have to say that this became very exhausting. I feel like this was way too large a project. This is my learning from this, that I sort of, set the target way too high. I'm happy that students were able to reach this, but I don't think it's fair on them for me to be expecting so much. So towards the end, I feel like the two concerns that I experienced from this were too large a model. And second, when you're not choosing your own problem, people are not as motivated. And healthcare for a business school student is not the most exciting problem. So those were the things that I took away from it. But I have more to share. So I will quickly talk about a little bit of the student-driven learning format here. And for this, let me just check where this is. Okay, so now we had interim submissions and students have given in their models. At this point, we sort of scrambled different submissions and shared a rubric with students, which was sort of shared in advance, and people had to grade other students on the basis of that rubric. So this is the peer-driven feedback mechanism, and this is what the rubric looks like. So it's a little bit of me bringing in my consulting hat into my teaching hat. So there was a little bit of that merging happening. And this is a Google form in which now each individual was, okay, so I saw a question over there. Each group had 4 students and they had the choice to make those groups themselves, but we sort of supported the creation of those groups. So people could join together if they wanted to. And those were scored on the basis of at a group level, but there was a concern, and this is also from the university. The university needed individual grading, for which there was a push for examinations. And I've seen that exams are not the best way to test system dynamics. And so for having personalized or individual component of grading, there was a peer review mechanism that was introduced, which did 2 things. One, which actually did a couple of things, but 2 primary things. There is now an individual component of the grading, which means within the group, people who have actually done a lot of work, it will be very evident on the basis of their reviews. And the second is now the groups get abundant feedback. So this sheet was shared with everybody, each group. So we had around 55 students, I think. And so each group, each person got 2 other models to review and critique. And as part of this, between the 4 people, they're covering 8 groups. So they are now seeing different models that their peers have submitted, and they can sort of learn from them. And they are reviewing them. And these reviews that they are giving are not enforceable, which I have seen. So I've also sort of designed curriculum at a couple of universities more broadly, not system dynamics. And I've seen that a lot of times people introduce these peer review mechanisms, which are just politically a nightmare, where students, it just creates a lot of dissonance within the group, because now somebody else is reviewing and rating me and you don't know, and that is going into my grade. And if you're friends, which is often the case, how much can you really trust that grade, right? And so these grades or these evaluations were not feeding into people's actual grades, but this was actually feeding into your grade of how well you've done the review. So I will showcase that, but very quickly, the rubric sort of talked about key sectors, key structural elements, whether you have the basic feedbacks or not, whether the model has data fidelity, whether there is behavioral fit or not, whether there are clearly derived insights. They presented a PDF presentation as well along with this. And then a bonus score, which I feel, how do you enable flexibility in a rubric as structured as this, right? So are there any exceptional features and considerations that go beyond the core evaluation criteria? And so within this, is there any flexible use of capacity? Have they deepened endogeneity in some interesting way? Anything else that merits an additional score? So any interesting things that you can think about, like just drop it over here. And we got really interesting comments over here. And then final review, which is more qualitative about what was great, what are the recommended improvements, and your notes and observations and learnings for your model enhancement. So now that you've seen this model, what will you take away to your own model? And okay. So this is what the response form looks like on the backend side. So people have given numerical scores, and then there's a lot of qualitative detail with respect to what was great, additional notes and observations, etc. And then I sort of just ran a pivot table to look at, is there enough consensus in the feedback that different people have for certain groups? And what I saw was that across the min, max, and average, there were certain groups that were emerging as the top groups. There are certain groups that are just consistently scoring comparatively lower. And then what are the averages across all of these questions? And there also you can sort of see a trend. So it sort of gave me a lot more confidence in the fact that people's reviews are actually sort of making sense, right? And now, if I really look at it, this is 108 feedbacks. Like, I personally could not have done that. Actually, it should be more than that. County of review group. Oh, no, so this would, it would be a sum product actually for each group, 108 into 13, yeah. So there's just like abundant feedback over here. And then I use the same form to add my feedback on top of the feedback that was already there. And so from a reviewing process perspective, it just became way easier for me to look at what's already been said. So which models I can look at in what detail, what are the gaps in those models. And so I had to sort of top that up. And then additionally, I sort of scored each person on what the score of their review is going to look like. So is their review really detailed or not? How good is it? How well has it captured the dynamics, etc.? And there was a little bit of just, like there were groups that were great, and there were people that I wanted should review certain groups' models because they were a little more advanced in the process. And so those were sort of just manually done to make sure that the individual reviews are really reflecting the skill level of different folks. I will, again, pause over here in case you want me to sort of read out a couple of these. I can do that. But in the interest of time, I also think we should. Any questions? The models were quite different, John. So the group that I showed is actually one. There were two groups which really, really did well. And this was one of them. some groups were struggling with basically, there were errors in their model. And that's basically at the interim stage, their submission, it had errors. So from this, they got a lot of feedback that would help them improve their model. Also, now the models are public, so they could also copy, but that's fine because I don't think that you need to sort of punish students for that. The other intention over here was that people are on their learning curve. So I wanted to grade the learning curve and not their actual skill levels, which is another thing that I feel is a little bit problematic about the current grading system. So here we are looking at how well have you sort of pivoted away, how well have you taken away all the lessons that you have. All right. So yeah. So now coming to the fundamentals that you can sort of take away from this. One is it a learning focused or an outcome focused evaluation? This was very learning focused. And at the same time, I sort of tried to decouple the amount of effort that it would require me. That is still not to say how much effort it takes to do grading for system dynamics models, especially something this complex. I actually measured, and for a good model, it was taking me almost 4.5 to 5 hours, which may say something about my speed, but like that's how long it took for me to look through the peer feedbacks, look through the model itself, figure out where I can offer incremental feedback, etc. Then there was a self-assessment and reflection. People are now thinking about what they've learned so far, peer feedback integrated into final grading. So now, while you have given feedback on others' models, you are getting graded for that feedback. So it's actually surfacing. There were some students who came to me who said that they were sort of stuck in certain groups which were not working out, and they were not able to do the modeling part very well. But I could see from their reviews that their understanding was really thorough, and they were able to sort of apply it with the models that they were looking at. And now the other advantage is that when you see all submissions, there's also collective benchmarking. So now it's not like one person is just way too far and another person is lagging in the back. This is almost like a normalization situation where everybody sort of sees everybody else, and you can allow people to learn from each other. And so I feel like the modern classroom has so much potential with all these students who are working on a problem. So how do you make them interact with each other? And now what it would take, this is not easy to undertake, but flexibility in curriculum design, which I've had some challenges with, institutional will to sustain experimentation, committed faculty and trained TA support. I did not have TA support, and that really sort of hurt the course a lot. Another piece that I have realized is that being co-located is important. I was not co-located during this entire time. So I used to sort of fly in for classes and then have to depart, which came as feedback from the students as well, that was not the best model because they could not access me. And then the classes were also happening in chunks instead of having a certain rhythm, which I think systems thinking requires that rhythm to sort of build that capability. And yes, enabling infrastructure. Vensim PLE has been a godsend for ages. Then MIT and Global ST simulations. We use the beer game. I forgot to mention that. But after we did the vaccinations, etc., and before we started with this model, we did beer game to, again, land the concept of complexity, etc. And then classroom equipment. I saw one classroom which had smart boards, which was very useful because now you build all of these models and they're saved. So students used to go there and then save and download those and distribute it to the entire class. I don't have that technology else everywhere, but it's really useful. And yeah, a lot of patience and support. I'll open this up for questions, which it was already open for, but curious to hear any reflections and thoughts.
I have a question. Thank you for the explanation and clarification. So this is very helpful. So this is not much of a comment, but as part of your conversation, you talked about George Peterson's model teaching conversation. Am I correct? Did I hear you correctly? And you recommended.
George P. Richardson, yes.
Can you type that in the chat,
Yeah,
please?
I'll drop one link. I have the website open.
I think there was one more reference that you recommended to use or to watch, and I don't remember the name exactly, but in case you remember.
I talked about Nikki's Romeo and Juliet, probably.
I don't remember exactly, but that was something you recommended that it's good probably to be used or to watch.
Yeah.
But it's okay, don't worry. Thank you so much.
No worries. Nikki's actually here. Maybe she can talk about it.
Yeah,
Or like,
I think Nikki's name. That seems yeah. I think
Yeah.
maybe that was related to the board sessions.
mhm. I actually have questions for the group then, if nobody has questions for me.
Actually, there's a question in the chat there that John put forward on the sequencing of the causal loop diagram versus the system dynamics modeling. It's similar to some struggles that I've experienced with like using systems thinking as the overarching aspect, but then how do you transition that to system dynamics or the mathing of it? So I'm curious what your experience is too on that.
So I don't spend too much time on CLD as like we do classroom CLD building, but we've not done CLDs as part of any assignments. The assignments are mostly about stock and flow, and it's more mathematical, therefore. So CLDs almost would take place in the first 5 lectures, where again, you're sort of learning about feedback loops, where you're learning about the interactions and how to connect different pieces. And a little bit of the mathematical notation also flows into it.
One of the things I'll just comment on quickly, and one of the reasons I put that question in there is that I found that by starting with thinking in stocks and flows and then taking the same kind of system and asking about it from a CLD perspective, students and I figured out that the CLD approach can be highly misleading. That it can lead you to some very confusing thinking about what's going on in the system. So anyway, just that comment.
I've read a paper by, I think again, George Richardson only, who talks about the problem with causal loop diagrams. And he mentions this, that you don't really understand, again, the parameters and what is, how much weight to give what and what are the relationships. So I also agree with you. I think CLDs to me can get very misleading very fast. And developing a consensus on the structure has been harder for CLDs. So it's almost like CLDs are harder to teach than stock and flow diagrams. But I feel CLDs have been useful in nonprofit work when you want to get people together and reflect on something. But I still feel that stock and flow diagrams hide the underlying mechanisms.
Yeah, it's so interesting. Thanks for that. I've actually had like the opposite experience. And causal loop diagrams are like a great way to get people thinking holistically and broadly, whereas the system dynamics can be, depending on their background, can be pretty limiting because you need the variables or data or like those like harder inputs in a holistic perspective. So cool.
Yeah. I think in nonprofits also, the problems that you're working with are not very transferable. Like there's some disabilities work that I've done, which is around inclusion, and it's very hard to translate that to a system dynamics model.
That's right.
All right, so I was saying I had a question. people over here who are maybe doing research or publishing, I wanted to just see if there's, applications of this that we discussed that you see from a research perspective, or how would you think about experimenting and seeing the results of the learning journey? Never mind. That's a question that I can mull on for longer. Okay, this has been great. I would, if you want to reach out, this is my email address. And I'm also on Twitter, which I'm guessing none of. I don't think the systems community loves the current model of Twitter, but this is my handle.
Thank you so much, Akriti. This was really insightful session, and thank you everyone for participating and being so engaging. Yeah, hope to see you in the next few webinars. We already have a few ones scheduled, so you can go to systemdynamics.org/seminar series and sign up for our next events. To see you all there. Thank you, everyone.
Thank
Have a
you.
good.
Thank you.
Bye-bye.
Bye.
Thank you. Thanks for showing up, folks.